Today we learn the aerospace engineering. Aerospace engineering from from the basic basic to advanced. Part one. At first, part one. Fundamentals fundamentals of aerospace 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 engineering. Aerospace engineering. Under part one, chapter one is introduction to aerospace engineering. Introduction to aerospace engineering. This is chapter one, introduction to aerospace engineering. At first, the definition. What is aerospace engineering, or A? Short term is A. Aerospace engineering. What is A? Definition. 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 What is aerospace engineering? Aerospace engineering, or in short, A, is the branch of is the branch of engineering with the design, development, testing, and production and production of aircraft. Production of aircraft. Aircraft means that fly within the Earth's atmosphere. Aircraft and spacecraft. Spacecraft means that travels beyond the Earth's atmosphere. The Earth's atmosphere means space. Aircraft, yes. Spacecraft means which travels in deep space or beyond the Earth's atmosphere. The aerospace engineering or AE, it consists it consists of two major branches. It has two major branches. What is that? What is this? These are aeronautical, aeronautical engineering, nautical engineering, and astronautical engineering. Astronautical, sorry, aeronautical and astronautical engineering, astronautical engineering. What is aeronautical engineering? Aeronautical engineering. It focuses on vehicle flying in the Earth atmosphere only. It focuses this these branches focuses on vehicles vehicles flying on the Earth's atmosphere. Only. Example: airplanes, airplanes, helicopters, helicopters, etc. Now the definition of or what is the astronautical engineering? Astronautical engineering, astronautical engineering. It focuses on vehicles operating in space. It focuses on vehicles operating that is operating in space. Operating in space. Example: rockets, rockets, satellites, satellites, spacecraft, etc. Now we know the key areas. Now we know about the key areas of a study. At first, aerodynamics. Aerodynamics is the one field of the study. It's its study of airflow and airflow. Sorry, over bodies. Over bodies means spacecraft or airplanes bodies. Number two, propulsion. To propulsion. Propulsion. How produce? Here study how produce thrust. Thrust. Number three, structures. 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 Here you study to design. How to design lightweight. Lightweight. Lightweight but strong bodies. Strong bodies. Next, flight mechanics. Next we study flight mechanics. Next we have to study flight mechanics. Flight mechanics. How? Here we study how aircraft fly and maneuver. And maneuver. The maneuver. Next we study. Next we study about control system. Control system. Control systems. Here we study how to maintain stability. How to maintain stability and control flight and control flight. At least you have to study space systems. Space systems. Here you have to study satellite and spacecraft systems. Satellite, satellite and spacecraft. Spacecraft systems. Systems. This is all the these all are the key area that we have to study. in aerospace engineering. Then we know about the historical historical evolution of aerospace engineering. At first, the story of brothers, Wright brothers, Wright brothers at the year 1903, 1903. They developed they developed the first the first controlled power fight, fast controlled and powered powered flight. Then WW1 and WW2 WW2 who developed were developing whereas developing major advancements in fighter aircraft. Major advancements in fighter aircrafts. aircrafts. Next, next there was the start of jet age. Jet age. Jet age. Post WW2. Here developed or introduction of jet propulsion. Jet jet propulsion. Jet propulsion. Then at least the space age. Space age. It starts from the year 1957. Onward, it starts from the 1957 onward. In 1957, launch we see the launch of Sputnik, Sputnik, Sputnik satellite. First, first first artificial satellite. First artificial satellite. Sputnik 1 was the Sputnik 1 was this first artificial satellite. Then in space age 1969 there was there started the There was start the Apollo 11 moon landing. Apollo 11 moon landing. Apollo 11 moon landing. And now today we have the present day. Present we see at present we see reusable, reusable, reusable rockets, rockets in SpaceX, SpaceX, SpaceX satellite, satellite, satellite constellation, satellite constellation, satellite constellations, satellite constellations, Mars mission, Mars, Mars mission, Mars mission, etc. Now we know the difference difference between spacecraft, difference between aircraft, aircraft and spacecraft, spacecraft. The difference of aircraft and spacecraft. At first, we know the difference in the features, features of aircraft and spacecraft. Aircraft and the features of spacecraft. Features aircraft spacecraft. Features is the operates so operates in It operates aircraft operate in Earth atmosphere. Earth's atmosphere. And the spacecraft operates in outer space or deep space. Outer space. The propulsion features. The propulsion features of aircraft is jet engines, propellers, etc. Jet engine, jet engine, jet engine, propellers, propellers, etc. And the rocket engine, and the rocket and spacecraft propulsion system is rocket engine. Rocket engine, rocket engines. Aircraft, aircraft leaves generation, leaf generation is aircraft aircraft generally lives by uses of wings, and spacecraft does not live in space. Live in space. Then features is the navigation system. Photographs. Um, Navigation system or the navigation or simply the navigation. Its navigation is aircraft's navigation is aerodynamics aerodynamic control system, and its spacecraft navigation is thrusters, gyroscopes, etc. Thrusters, thrusters, gyroscope. Aircraft example is now the feature is example. Difference is the features of example. Aircraft example is mm, Boeing Boeing 747 F-16 glider F-16 glider Boeing 747 F-16 glider is the example of aircraft. And spacecraft example is SpaceX Dragon SpaceX Dragon, Voyager Voyager ISS, etc. Now now we know the basics of flight. Now we know about the basics of flight. Chapter 2, Basics of Flight. Basics of Flight. Number 1, Chapter 2, Number 1 is the introduction of forces, introduction of forces on an aircraft means planes, helicopters, etc. When its flight is subjected, aircraft when flight is subjected four main forces, four forces, four main forces. The force are, let's draw the image. Force description, force, sorry, force direction and description of the force. Description. Force is if lift L. Force is lift L. Its direction is in the upward direction. It's generated. The lift generated by wings to counteract weight. To counteract weight. Then weight. Then the force is weight W. Its direction in the downward. 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 It is the gravity. It is due to the gravity. Gravity of Earth. Gravity. And it arises due to the mass of the aircraft mass of the aircraft. And another two forces is the first, the thrust th thrust t. Its direction is in the forward direction. Forward direction. And it produced the thrust produced by the engines to propel to the aircraft. And last force is the drag D, and its direction is in the backward direction. Backward direction. Backward direction. And is oppose the air resistance. Sorry. And it's produced by the air resistance. Produced by the resistance on the plane or helicopters. Resistance. Resistance of the aircraft. Now we know the condition. Now we know the condition for a steady fight. Now we know the condition. Now the condition for level and steady flight. Number one condition is lift equal weight. Number two is thrust equal drag. If these two conditions means if the aircraft lifts equal aircraft weight and aircraft thrust equal to the drag of the aircraft, then the aircraft fly level steady. Fly level and steady. Chapter 2, number 2 is how lift is generated. How we know the how lift is generated. How lift is generated by the born by the Bernoulli's principle. Bernoulli's principle. To understand lift, we have to look at the airflow around a wing. We have to look at the airflow, airflow, airflow around a wing, around a wing, airflow around a wing. Airflow around a wing is called airfoil. Airfoil, airfoil. Now we know the Bernoulli's equation for incompressible and steady flight. Steady flow. Now we know the Bernoulli's Bernoulli's equation for for incompressible incompressible steady flow. Steady flow. What is the Bernoulli's equation? Bernoulli's equation is P plus half rho v square plus rho gh equal constant, where P the static pressure, the static pressure, pressure, rho the air density, rho is the air density, rho is the air density, v is the velocity of airflow, velocity of airflow, h is the height, which is called altitude, and g is the gravitational acceleration, gravitational acceleration, acceleration. Now and we assuming that change assuming that height change is negligible, h is constant here. Height change in height or change in height h equal constant here for the Bernoulli's equation. Then the equation then the equation be half rho v square equal constant. As h equal constant, we say explanation of the equation. Explanation of the equation. Over the curved upper surface of a wing, air flows faster. Over the curved upper surface of a wing, air flows faster. Air flows faster. And faster air flow, faster, faster air flow, faster air flow, faster air means the lower pressure by Bernoulli. The lower pressure which is Bernoulli. And under the wing and, and under the wing and under the wing air is lower means high pressure, and under the wing under the wings under the wings air is slower means higher pressure higher pressure higher pressure. And this pressure difference between the under the wings and the between the under the wings and upper surface of the wings. This pressure difference between, if this is a wing, sorry, suppose this is a wing. This is not a good picture. This is the wings. Here is the upper surface of the wings. If we say, then their pressure is lower than the its lower surface. Its lower surface. Lower surface pressure is greater than the upper surface pressure. And this pressure difference between two surface of the wings, this pressure difference between two surface of the wings lifts creates lift, and the aircraft is going forward for the lift. And chapter 2 number 3 is chapter 2 And the chapter 2, our discussion is chapter 2 number 3 is Newton's third law interpretation. Newton's third law interpretation. Interpretation. And we discuss this in the next video lecture for this series, for this